In this presentation, we propose a CAMARA as a service approach that enables network operators to control already existing services exposed through TMF APIs. This approach leverages standardized TMF APIs and middleware layers to integrate CAMARA APIs seamlessly with existing 5G or beyond 5G services, minimizing the need for extensive modifications to current services. To demonstrate this concept, we showcase a practical use case: controlling an already existing QoS profile enforcer service for 5G user equipment through a CAMARA API. This service, exposed via TMF APIs, dynamically manages QoS profiles for 5G UE. By integrating CAMARA APIs with this service, we illustrate how operators can offer these novel APIs for dynamic QoS management without altering their underlying infrastructure and services. Through this demonstration, we aim to highlight how the CAMARA as a service approach empowers network operators to expose CAMARA APIs efficiently, enabling seamless integration with their already existing network services. Let us start by introducing some background concepts. 5G represents a transformative leap in wireless communication, offering significant advantages. First, it provides enhanced network capabilities, including higher data speeds, greater capacity, and ultra-low latency, which are critical for real-time applications. Second, 5G networks are highly programmable and flexible, enabling tailored solutions for diverse industries such as healthcare, automotive, and manufacturing. Finally, 5G drives innovation across sectors by supporting advanced use cases like the Internet of Things, augmented reality, virtual reality, and smart cities. Despite its potential, 5G adoption faces significant challenges. Industry-specific applications often struggle to integrate with complex network control functions, requiring developers to have deep telecom expertise. Limited accessibility to simplified interfaces slows innovation and reduces the ability to fully utilize 5G capabilities. To address these issues, a solution that bridges the gap between applications and network functionalities is needed. This brings us to the CAMARA initiative. The CAMARA initiative simplifies the complexities of telecom networks by standardizing APIs that abstract advanced network functions. This allows developers to interact with 5G beyond 5G networks without requiring deep telecom expertise. By enabling application portability and seamless integration, CAMARA accelerates innovation through use cases like quality on demand. But how can network operators leverage these APIs without extensive modifications to their existing systems? This question is the base for this demonstration. During our demonstration, we will showcase how this can be achieved. But first, let's start by addressing the current landscape of network operators. An increasing number of network operators is adopting TM Forum's open digital architecture, which provides a modular framework for digital transformation. Through TMF-compliant APIs, operators can then expose products and services seamlessly, enabling streamlined service integration and lifecycle management. As just introduced, TMF APIs are becoming widely adopted as an industry standard for exposing and managing services. They enable lifecycle management and resource control, therefore providing a robust framework for CAMARA integration. Middleware layers can be used to translate CAMARA API requests into TMF operations, ensuring seamless compatibility with existing systems. By building on top of TMF's framework, our approach ensures a transparent CAMARA integration without requiring extensive modifications to existing services. In this sense, it is possible to rely on CAMARA APIs to simplify the access to existing 5G capabilities, all while fostering a unified ecosystem for offering innovative services. With this foundation in place, let's move on to our demonstration. Our demonstration highlights the CAMARA as a service approach, using Openslice, a TMF-compliant OSS platform, to expose a QoS profile enforcer service. This service manages QoS profiles for 5G user equipment in a standalone commercial-grade network. The demo focuses on how CAMARA APIs integrate with TMF-exposed services to dynamically control the quality of service of 5G user equipment. Let's now delve into the details of the existing QoS profile enforcer service. the legacy service. The first step is to go to Openslice, the TMF-compliant operation support system that we already addressed. There, it is possible to order the QoS Profile Enforcer service, the legacy service. When you order this service, you are prompted to configure various parameters that relate with the profiles available for the 5G UE that shall be controlled through this service. After that, you should acknowledging this service order. This will lead to the deployment of the QoS Profile Enforcer service. Now let's have a look at the service characteristics. Please notice that besides the initial parameters, we also have other parameters that relate with the enforcement of the various quality of service profiles we have initially configured. When a service was ordered, its default profile was configured with a maximum bitrate of 10 megabits per second for both uplink and downlink. Now, we will check if the UE is actually using the default QoS profile. As you can see, the UE has access to 10 megabits per second of uplink and also downlink. Now, we will update the service characteristics in order to enforce a new QoS profile on this UE. This is all done through Openslice UI, but can also be achieved using the TMF APIs exposed by Openslice. Now you can see that profile low was requested. To prove that this service is working properly, we have to validate if the profile low was enforced. Therefore, we perform another speed test, and indeed, the uplink and downlink are aligned with what we have defined for the profile low. So, we can affirm that the legacy service is operating correctly and controlling the quality of service profiles applied on the 5G user equipment. We now demonstrate how CAMARA APIs integrate with the existing QoS Profile Enforcer service, which is exposed via TMF APIs on Openslice. A middleware component plays a critical role here by translating incoming CAMARA API requests into TMF 638 service inventory management operations. This ensures seamless control over the existing service without requiring any modifications to the underlying systems. The architectural diagram we now present reflects this approach. Let's start by breaking down the workflow for making available a CAMARA middleware, which besides exposing a CAMARA API, also offers a middleware that translates the requests received by such API to TMF operations on the already existing QoS Profile Enforcer service. First, the middleware is ordered and deployed via Openslice, referencing the UUID of the existing QoS Profile Enforcer service. Steps 1, 2, and 3 colored in blue. Once deployed, the middleware exposed a CAMARA REST API to dynamically manage QoS profiles. In this case, we rely on the CAMARA Quality of Demand Provisioning API. Step 4 colored in blue. When this API receives a request, it is translated into TMF-compliant operations that interact directly with the existing service, thus enabling the control of the QoS of 5G user equipment. The steps colored in green. The benefits of this approach are significant. An operator can now offer advanced features through this CAMARA API, all while maintaining compatibility with its current infrastructure and existing services. This integration simplifies operations and accelerates innovation in 5G service offerings. Having described the workflow for offering the CAMARA middleware, we now move on to see how the presented architecture manifests itself. As said before, the first step to deploy the CAMARA middleware is to go to Openslice and order it. The middleware must reference the UUID of the service that will be controlled, in this case, the legacy QoS Profile Enforcer service. We start by collecting the service UUID and then order the CAMARA middleware, referencing it. Then we acknowledge the service order, in order to deploy the middleware service. When the service becomes available, we can look at its characteristics. Please notice that there are several service characteristics. When the service becomes active, it exposes in its service characteristics the URL where we can find the CAMARA API that was just made available. The first step to validate this deployment is to confirm that the 5G UE is using the default QoS profile we have previously configured. As we can see, that is what is happening. Now we can rely the CAMARA API to control the legacy QoS profile enforcer service and, by doing so, control the QoS profiles that are assigned to the 5G UE. Therefore, we will use such API, in this case the CAMARA Quality on Demand Provisioning API, to request the enforcement of the profile low. As you can see, the API response contains a provisioning ID. Through the same API, we can use this ID to check the status of the QoS profile enforcement. As you can see, the QoS profile was requested, but it is still not active. If the CAMARA middleware and its exposed API are working properly, the request made to the API should be reflected on the legacy QoS profile enforcer service. We can confirm this by looking at the service characteristics. Please notice that the characteristics were updated and reflect the request made through the exposed CAMARA API. After a while, the legacy service will enforce the QoS profile, as it was demonstrated before. If this takes place, the legacy service will expose information that proves that the QoS profile was enforced, which is what you can see now. If we go once again to CAMARA middleware service, we can see that this service consumed the results that were exposed by the legacy service, and therefore is aware that the QoS profile has been enforced. This information is not only available on Openslice. It can be obtained by invoking the exposed CAMARA API. Now we will use this API to check the QoS profile enforcement status. The QoS profile was indeed enforced. We can also perform another speed test. And, as expected, we prove that the QoS profile low has been applied. This proves that our CAMARA as a service approach is a feasible way of managing legacy services through novel CAMARA APIs. In conclusion, the CAMARA as a service approach enables telecom operators to expose existing services with minimal modifications by leveraging middleware solutions built on TMF APIs. This ensures compatibility across diverse systems while accelerating the adoption of advanced use cases like quality on demand. Still, many others are supported by our approach. Looking ahead, the approach we have presented in this video can pave the way for innovative API offerings in the telecom industry, fostering a unified ecosystem that drives rapid development and deployment of industry-specific solutions offering straightforward APIs, such as the CAMARA ones. We express our gratitude to Andre Perdigown for providing us with a simplified API to manage 5G resources, which was crucial to enforce UE QoS profiles. We would also like to thank Eduardo Santos for having implemented the original QoS profile enforcer service, which was later exposed through the CAMARA API, and for composing this demonstration video. Thank you for watching our demonstration. We hope this video clarified how network operators and communication service providers can leverage CAMARA APIs without extensive modifications to their existing systems. If you have any questions, feel free to reach out. Thank you.